Welcome to qnawire.
So we're told that we're going from the M shell, which n equals 3 in sub I, to the N shell, or excuse me, K shell, where n is equal to 1. So n final is equal to 1. And we get a wavelength lambda of 101 nanometers, or excuse me, 0.101 nanometers. The energy from this transition, E, is going to be equal to hc over lambda. But it's also equal to E sub 3 minus E sub 1. We have E is equal to E sub 3 minus 1. E sub n in general is equal to negative 13.6 electron volts times Z minus n squared. Oh, sorry, the square should be outside of that parenthesis. Right there, let me fix that real quick. So this is times Z minus n, all that quantity squared, times 1 over n squared. So if we replace n with 3 in these equations, then we can solve for Z. So this is E minus E1. So we're going to let E equal hc over lambda. So what we have is c over lambda is equal, well, bases have negative 13 EV, so we can pull that out. So we have negative 13 EV. And this is all getting multiplied by, so the first one is Z minus n, where n is equal to 3. So we have minus 3 all squared, 1 over 3 squared, or in other words, 1 over 9. And then we're going to subtract from that Z minus 1 squared times 1 over 1 squared, which is just equal to 1. So this is just Z minus 1 squared. So now we can start to solve for Z. So maybe we should carry out these squares here. So what we have here, I'm going to put everything with Z on the left side of the equation and everything without Z on the right side of the equation. So I'm going to divide by negative 13.6 electron volts to get hc over negative 13.6 EV times lambda. That's going to be on the right side of the equation. So the first thing we're going to do is carry out the square for this Z minus 3 squared times 1/9. So we have, if we do that, the first thing we have is Z squared over 9 we have minus, so negative 3z minus 3z is negative 6z divided by 9. So we have negative 6/9 z. And then we have negative 3 times negative 3, which is negative 9 divided by 9. In other words, negative 1. And then we're going to subtract from that. So the first one is z squared, right? Z times z squared. We have negative 1 times z minus 1 times z. So that would be negative 2z, but then there's a negative sign out front, so this becomes a plus 2. And then the last one is just negative 1 times negative 1, which is 1, and then we have a negative sign out front, so that becomes negative 1. And all of this is equal to hc divided by 13.6 EV times lambda. There is a negative sign, so we don't want to forget that, so we can put it up top. Negative 13.6 EV times lambda. So now we can simplify a little bit. So we have z squared over 9 minus z squared. This gives us negative 8/9 z squared. Then I have negative 6/9 z plus 2z. So negative 6/9 z plus 2z gives us positive 8/3 z. So this is plus 8/3 z. Then we have negative 1 on the right side. Oh, excuse me, this should be positive 1, right? Because we have negative 3 times negative 3, which is 9 divided by 9. So this is a positive 1. So we have plus 1 and then a -1. So those are going to cancel out. And then we still have all of this being equal to negative HC divided by 13.6 EV times lambda. But let's put all of it on the same side of the equation and then use the quadratic formula to solve for z. So this is plus, and again, this -1 cancels with +1, so let's cancel those. So this is plus HC divided by 13.6 E times lambda. And this is all equal to 0. So we can use the quadratic formula to solve for z. So we have z is equal to, remember the quadratic formula, negative b plus or minus the root of b minus 4ac all over 2a. So this is negative b, which is 8 in this case. This is negative 8/3 plus minus the square of b squared. So this would be 8/3 squared minus c is negative 8/9. So this is minus times negative 9 c, where c is 8 divided by divided by 0.6 EV lambda. So multiplied by h. So for a Planck constant, we want to use the electron volts seconds version, not the joule second version, because we're dividing by electron volts. So we want those units to cancel. C, of course, we're just using the speed with units of meters per second. Times, remember, it's given at the beginning, all divided by 2a, where again, a is negative 8/9. So this is 2 times negative 8/9 by negative 8. Let's redraw. Do it like this. Okay, so of course this is going to give you two answers because of the plus or minus. We want to take the answer that makes the most sense, right? So this comes out to equal 32. The answer that we can ignore the other. Look up which one has 32, and this is germanium. So we can box this in as the solution to our question.